Hi folks, here's page 187, number 15. So they give us this position function here, and in A they want us to show that the acceleration is constant. Now, you should actually be able to tell right off the bat that the acceleration is going to be constant because the position function is a quadratic. Hence, when I take the derivative, I'm going to get a linear function, which is the velocity, and then when I take the derivative of that, I'm going to get the acceleration, which should be constant. Okay, but let's actually do the work. So the first thing we'll do is find the velocity, which of course is the first derivative of the position function. And so here I've got k is just a constant, so I've got 2kt here. And then plus, this whole thing is just a constant times t, and the derivative of t is 1. So I'm just left with 6k squared minus 10k. And then when I take the acceleration, which is the second derivative of the position function and the derivative of the velocity, the only term that remains is this first one. Derivative of t is 1, and here my constant 2k. Okay, and these are all constants, so the derivative is 0. So here we've shown that the acceleration is constant. Okay, so don't get fooled by all these k's here. They're all constant. The t is the only variable to work with. Okay, in B, it says find the time at which the velocity is 0 and determine the position of the object when this occurs. So we already have the velocity. Okay, so I'm going to set that to 0, and here we've got 2kt plus 6k squared minus 10k. So let me solve for t. So I'll keep the 2kt here, and I'll bring those to the other side. So I've got 10k minus 6k squared, and so t is 10k minus 6k squared over 2k. Okay, and let's simplify here, because I can factor out a 2, which will get rid of the 2 there, and I can also factor out a k, which will reduce the k in the denominator. So essentially nothing left in the denominator. The only thing I'm left with in the numerator here would be factoring out a 2k. I'll be left with a 5, and here factoring out a 2k, I'll be left with a 3k. Okay, so at time 5 minus 3k, the velocity is 0. And they want us to find the position of the object when that occurs. So now I just take this value of t and I put it into my position function. So I need to find s at 5 minus 3k. So that's going to be k times 5 minus 3k squared plus 6k squared minus 10k times 5 minus 3k, and then plus 2k. Okay, so here, this is a good test of how quick we are with our algebra skills. So this is k times, so let's square this binomial. So square the first, 25, 2 times 5 times negative 3. So this is going to be minus 30k, and then plus 9k squared. Okay. Now let's multiply these two binomials. So we've got 30k squared. Let's see, what else do we have? Minus 18k cubed. Okay, then we've got minus 50k. And then here we've got plus 30k squared. And then plus 2k. Okay, and now let's simplify this here. So let's find all the k cubes. So here we've got 9k cubed minus 18k cubed, so that's negative 9k cubed. Let's go for anything with k squared. So here we've got negative 30k squared plus 30k squared, so that's 0. But then we have another 30k squared there, so plus 30k squared. Let's go for the k's now. 25k minus 50k, that's negative 25, plus 2k is negative 23k. And we've got all the terms done. Okay, so there we have it, our position at the time when the velocity is 0. Okay, so I'm just going to pan out here so that you can see the whole solution if all you need is the written version. Okay, so that's it for this one.